Courtney Gendron, who's going to do our webinar tonight on a very interesting topic that I personally will learn about also for the first time. So we're excited to have her here with us and doing this webinar. As Rita mentioned, if you could keep your cameras off and on mute during the webinar, that would be great. Just one second. I'm going to pull up Courtney's bio. So as an introduction, Courtney Gendron is a certified industrial hygienist based in Sudbury, Canada. She has over 10 years of experience within the disciplines of EHS and community health, focusing on preventing and managing occupational hygiene hazards within the mining industry globally. She's provided occupational hygiene services to rare earth element mining projects and operations internationally, and has been invited to speak on the topic at a variety of different conferences in recent years. Courtney is currently the vice chair of the American Industrial Hygiene Association's Mining Working Group. And with that, I'll hand it over to you, Courtney. Thank you very much.
Great. Thanks, Samantha, for the introduction. And thanks, everyone, for being here. So I, like Samantha said, have worked in rare earth element mining. And my first project that I worked on was back in 2019. And at that point, I didn't know anything about rare earth element mining. I knew a lot about mining, but it was a new type of mining that I wasn't used to yet. And out of that, I realized that at least in North America and Canada, there was not a lot of guidance for assessing occupational hygiene risks in this industry, at least for their unique risks of rare earth element mining. So that's what I'm going to focus on today. So I'm just going to share my experience from that first risk assessment that I did. And since then, I've been involved in a few more rare earth element projects, mainly during the early phases of the projects before production, which, as we know, is the best time to anticipate the risk and plan for control. So it's really exciting and interesting that I'm getting those opportunities to share the knowledge before the mine is even constructed. So all of the information that I'm going to provide you today is from literature reviews and just general experience. I don't have any data to show you, unfortunately, but I have some data from the literature. So off we go. So this is our agenda for the day. I'm going to go over what rare earth elements are, especially because I had no idea whenever I started, so some of you might not know either, and give you an idea of what rare earth element mining looks like globally and why this might be an emerging industry and why it's important. I'm going to go over the risks to worker health and the legislation and guidance that are specific to the two unique hazards in rare earth element mining. I'm going to go over recommendations on how to conduct a baseline exposure assessment, and then leave you with a few considerations to help with preventing occupational hygiene health risks in this industry. Okay, so the first topic, overview of rare earth elements in mining. We're going to talk about what rare earth elements are, what they're used for, where they're mined currently, and why this is an emerging and expanding industry. So these are the rare earth elements. There are actually 17 elements on the periodic table. So they include the lanthanides, and also scandium and yttrium are also considered rare earths. And that's because they're found in the same ore deposits as the lanthanides, and they exhibit similar chemical properties. And the term rare is actually a misnomer. They're not actually rare. They're found in quite abundant concentrations in the Earth's crust, but they're not found in concentrated deposits like you would see something like gold. And so that's why they were called rare earth elements. They can be broken down further into heavy and light rare earth elements. You'll probably see this if you ever dive into the literature a little bit more. So this is based mainly on atomic weights. You can see that the lanthanides that have the lighter atomic weights are the ones that are classified light. And yttrium is lumped into the heavy rare earth elements because of it's more similar in terms of its chemistry and physical properties, and it's related to its trivalent radius. And the light and heavy rare earth elements are found in slightly distinct deposits. And so a rare earth element mine might focus on either heavy or light rare earth elements, and they're also used in different industrial applications. So this is what they're used for, just at a glance. These are the rare earth element uses in 2021 based on the Government of Canada website. So rare earth elements have very unique magnetic and optical properties and makes them really important for a certain number of industrial applications. They're actually sometimes called the world's industrial vitamins because they're essential for what they're used for, but they're used in very minute concentrations. So permanent magnets are the single largest end use for rare earth elements. As you can see, in 2021, they're used for 30% of the applications. And neodymium, which is one of the rare earth elements, iron boron magnets are the strongest magnets known. And they're used in a lot of green or energy efficient products, including the magnets in wind turbines and in electric vehicle motors. We also have lanthanum, which is another rare earth element-based catalyst, are used to refine petroleum. We have cerium-based catalysts used in automatic catalytic converters, and the glass industry uses them as additives that provide color and special optical properties. So those are some of the applications for rare earth elements. Okay, and so as we know, the world is going through a major transition towards cleaner energy. I talked about electric vehicle motors and the magnets in wind turbines being a use for rare earth elements. And so we know that this major transition is going to demand substantially different resources than those required by the current energy system that's powered by traditional hydrocarbon materials. And so we sometimes hear what's called critical minerals. So clean energy technologies rely on these critical minerals. And these are some of them up here. There was a report that came out from the International Energy Agency, or the IEA, in 2022. And they found that some of the critical minerals, such as these up here, we don't have even close to the amount of supply that's required to meet the Paris Agreement goals. So this is the increase in the amount of these critical minerals that's required to meet the goals in 2040 relative to 2020. So we need 42 times the amount of lithium in 2040 as compared to 2020, and 7 times the amount of rare earth elements. And so this is just to show that this is part of the reason why this is an emerging industry or an expanding industry in some parts of the world, because we need a lot more rare earth elements if we are to use windmills, especially in the green energy transition. And some minerals, such as cobalt, have a higher recycling rate, but unfortunately at this point in time, rare earth elements, the global recycling capabilities that exist for rare earth elements are less than 1%. So we are going to need much more supply of rare earth elements going forward. And this is a look at where they are currently produced, or they've been produced since 1985 all the way up to 2022. And this is global mine production. So you can see that China has the majority of the mine production globally, with the US in second with its one Mountain Pass rare earth element mine. And so this is the reason why it's an emerging industry outside of China, and especially in North America. It's been part of our government's plan to develop more rare earth elements to support the green energy transition and our green energy economy. And so that's the reason why we're seeing a lot more going forward. And this just illustrates this. So this is a headline in the Globe and Mail, and it says the U.S. and Canada are looking to secure its supply chain for critical minerals, and you can see all the different countries that we've partnered with, and so it's a buzzword in media right now, critical minerals and rare earth elements, and so our governments are pumping a lot of money into developing this industry. And this is a look at the current rare earth element mines, so the active mines, which are stars, and the advanced projects, which are circles here. So you can see it's quite distributed around the world. Most of the active mines you can see here are in China, and there's quite a few advanced projects in North America, which is normally what I deal with. And so there is 128 advanced projects globally. We have 16 in Canada of the advanced projects, and there's 10 in the United States. And Canada is actually developing its first processing facility, the first one in North America right now. Okay, so now we're going to go over the risks to worker health, focusing on the 2 unique hazards. Okay, so with any major economic transition that depends on the manufacture of new products, the extraction and processing of raw materials presents a new mix of hazards. And so for rare earth elements, this is the rare earth element particulate itself, and also ionizing radiation from naturally occurring radioactive materials or NORMs. And ionizing radiation is, you might think, is not unique, but it kind of is, at least in Canada and North America. And that's because thorium is not normally co-occurring in mineral deposits the way that we see it in rare earth element mineral deposits. And so we need to make sure that we address that thorium decay chain as well as the uranium decay chain. And also our legislation does not account for higher amounts of naturally occurring radioactive materials in mining operations that are outside of uranium mining. So that's what makes ionizing radiation unique. And we can't forget all the other ones. So the ones in red are the unique hazards here, but we also still have respirable crystalline silica, noise, whole body vibration, thermal stress, and other occupational health hazards that are on a rare earth element mining site that are general to most mining operations. But we will be looking at the rare earth element particulate and the naturally occurring radioactive materials, or what I'll call NORMs, going forward. Okay, so we'll start with the rare earth elements themselves. So the take home here really is that the research is limited, at least for the human data, the occupational data for the risks of rare earth elements. Most of the information that I have read are from 4 literature reviews. The most recent one is from 2021. And the existing data is mainly based on controlled experiments or lab tests on animals. The human data is primarily case reports of disease or bioaccumulation studies of people living in regions close to rare earth element mines in China. The case studies are mainly from movie projection workers. They're exposed to rare earth